Hi guys, let's have a look at activity 5-1 and we'll just read through it. A chilled water heat exchanger uses brine with specific gravity of 1.2 to cool water. The brine inlet temperature is 0 degrees F and the outlet temperature is 35 F. The heat capacity of the brine is 0.79 BTU per pound per degree Fahrenheit and the brine flow rate is 25 gallons per minute. The water outlet temperature is controlled, so that's the controlled variable, and the water inlet temperature is 55. The heat capacity of the water is 1 BTU per pound per degree F. So what we don't know is the water flow on the way out. And what the book doesn't really come right out and tell us is that energy is conserved. First law of thermodynamics says energy is conserved. In other words, the brine's heating up, so whatever heat goes into the brine has to come out of the water. And we have our formula here, Q equals C m delta T, and we can write this for the brine and we can write one for the water. And we know that we're also going to say that Q of the brine plus Q of the water equals 0. Okay, so for the brine, do we know this one? Yes. Do we know M? Well, they give us gallons per minute and we can get M. And we know both the temperatures, so we can get delta T. Now for the water, we know what the specific heat capacity is. Do we know M? No. They don't tell us how many gallons per minute. We have no direct way to calculate this, although we know this. So this guy's really what we're after. That's kind of the problem. So let's use the fact that we know these two got to add to 0, and we'll find Q for the brine first. So Q of the brine equals 0.79 BTU per pound per degree F, and we have 25 gallons per minute, so I'm just going to write that there, gallons per minute. And also this is Q has got to be in BTUs per minute. They don't tell us that either. We know it's 8.34 pounds per gallon of water, but this isn't water, is it? So we have to say that, in fact 1.2 gallons of water weighs the same as 1.0 gallons of brine. So really we have to multiply this 8.34 by 1.2 to account for the fact that the brine's a lot denser. So all this part, this is really our M from up here, and then delta T is going to be the temperature change. And we're going from final temperature minus the initial temperature in degrees F. So we've got 35 degrees delta T. So let's go ahead and do that. So Q of the brine equals, you can see what's going to happen here. Pounds is going to go with pounds. Degrees F is going to go with degrees F. Gallons of brine is going to go with gallons of brine. Gallons of water is going to go with gallons of water. Minutes and BTU are left over. So I've got 0.79 times 25 times 8.34 times 1.2 times 35. So Q equals 69.22 BTU per minute. So remember we said that if heat's going into something, it's positive, and if heat's going out, it's negative. So here's the brine, here's the water. Heat's going in out of the water and into the brine. So here comes Q of the brine, and there goes Q of the water. Whoops. So they're the same. So then we'll just say Q of the water equals 69.22. Now let's see what we got here. So Q of the water equals 1 BTU per pound per degree F times M, which we don't know yet, times delta T. And delta T is going to be final temperature, which is 35 minus 55. So it's a negative 20. Now I'm going to be kind of liberal with the signs. So this whole thing is really M times 20. So that's the heat that's coming out of the water. And if we add QW and QB, then we see that it's going to be 0. So M equals 69.22 over 20. And we can get right at the mass flow rate. So that's going to give pounds of water, and I think I get 346 pounds per minute, and that's going to go to 41.48 gallons per minute. Alright, so now we did it our way. We just whacked this whole thing all at once. And if you look at what the book asks, the book says, what is the mass flow rate of brine in pounds per minute? So they ask us that. We could just go through that and say, no, we've kind of already done that. So really, this part here, well, right here, that's the answer to question 1. 25 times 8.34 times 1.2. So that's question 1. Question 2 is, what is the amount of heat transferred to the brine in BTU per minute? And that's this number. What is the mass flow of water in pounds per minute? That's question 3, and that's this number. And what is the flow of water in gallons per minute? So let's see. We've got 346 pounds per minute divided by 8.34 pounds. Did I really use 8.34? I might have. Yes, I did. Okay, good. Pounds per 1 gallon. And this is going to leave gallons in the numerator and minutes in the denominator. The pounds will cancel. And that's where we get this roughly 41 gallons per minute. Okay, that's it for that one.